So if you're reflecting across the x-axis, you're actually moving up or down to cross over the x. If you're reflecting across y, you would be moving across. So let's look at these two examples here. If you're given the point 3, 2, and it asks you to reflect across the x-axis, there's a couple of ways you can do that. One way is I can see, first of all, that that's 1, 2 units above the x-axis, so I would reflect it 1, 2 units below. And that reflected point would have the coordinates 3, -2. If I reflect that same point across the y-axis, this is y, so I notice it's 1, 2, 3 units to the right. So I would reflect 1, 2, 3 units to the left. And that reflection would be at the point -3, +2. Now I want you to also notice the patterns in the coordinates. So this pattern will always be true. Anytime you reflect a point or a shape across the x-axis, the x coordinates will stay the same. In this case, I started with 3 and I still have 3 on the reflection. The y coordinate becomes the opposite. So I had 2 and the reflection was -2. It's the opposite if you reflect across the y-axis. Anytime you reflect across the y-axis, your y coordinate stays the same. You can see those were both 2, but the x coordinate becomes the opposite. So it went from 3 to -3. So it's actually easy to do these with or without having the actual picture of the graph. Let's say we have these examples below, and let's say we didn't have a coordinate plane. Well, if my original point is -2, -4, and I reflect across x, I know that the x coordinate will remain the same, and the y becomes the opposite. If I reflect across the y-axis, I know that the y coordinate would stay the same, but the x would become the opposite. If I have this point here and I reflect it across x, x stays the same, y becomes the opposite. If I reflect across y, the y coordinate stays the same and the x becomes the opposite.